Hello friends, in today's question, a cylindrical tube open at both ends has a fundamental frequency f in the air. The tube is dipped vertically in water so that half of its length is in water. The fundamental frequency of the air column is now. So we are given that we have cylindrical tube. So let us draw the diagram. So this is a cylindrical tube and it's open in the both ends. Okay, so if it's open at both ends, so at both ends we are going to get here it will be also air and here it will be also air. But when it is dipped in the water or liquid, suppose this is liquid and it says that half of the length is dipped. So total length is suppose is L. So if it's half of its length is dipped, so this is suppose the liquid, and now half of it, so L by 2 will be in the air and L by 2 will be in the water. So in this case, here we are going to have air at one end and the other end it will be filled with water. And total length is our L. So here major difference is that when it is air, both the ends are open, but as soon as we dip it in water, one end which is still in contact with the air is going to act as open, and the end which is in contact with the water is going to act as closed. So here, so this is our open end and this is our also open end, and with water this will be our closed end now, whereas in air it is also still as open. So this is the fundamental difference between the two. So let us say that first we are going to call it as a open air tube, and this we are going to call as a open closed tube. Okay. So this is our open tube and this is our open closed tube. So let us start with open tube. Open tube. So in this case, when it is open at both ends, the fundamental node is going to have two empty nodes at the ends and one node at the middle. Okay, this is the basic property of when the tube is open at both ends. So in this case, we can say the fundamental node has two empty nodes at the end and one node at the middle. And the fundamental frequency is already given, that in first case the fundamental frequency is f. So therefore we can say that f, which will be equal to v upon lambda, where v is the velocity of the sound in the air and lambda is the wavelength. So v upon lambda will be equal to v upon 2L. That is we can say a relationship between the fundamental frequency and the this open case. So where v is the velocity of sound in air. Now, as soon as the tube is immersed, you can say dipped in the liquid, tube is half submerged in water. So like I said, it is dipped vertical in the water, half of its length is submerged. So So it means only the top half is in contact with the air and the bottom half is submerged in water, which is going to act as our closed part. So therefore you can say that when the tube is dipped vertically in water so that it is half of the length, so that half of the length is submerged. So therefore you can say that only top half of the tube contains air now. Only top half of tube contains air, or we can say open, and the bottom end submerged in water now acts as a closed end. So it means because of this property, the tube is now going to behave as a open end tube. Okay. Therefore, when one end is open, which is the top, and one end is closed, that is bottom, the tube behaves as a open closed tube. So now we are going to find out the fundamental frequency for this condition, open closed tube, which we are supposed to find out in the question also. So we can say fundamental frequency of open closed tube. So as now the position of node and antinode is going to change, okay, or we can say that the number is also going to change. So therefore we say for one end closed and other end open, the fundamental node has a node at the closed end. Sorry, it has to be mode. Okay, fundamental mode, my mistake. I think here also put here node. It's not node but mode, fundamental mode. Okay, I think rest is correct. So it is going to have a node at the closed end, and it is going to have an antinode at the top end, closed node at the closed end and antinode at open end. So if lambda prime is the wavelength of the fundamental mode in this condition, open closed tube, so we say if wavelength lambda prime of the fundamental mode in a open closed tube, then we can say that this lambda prime is equal to 4 times multiplied by the effective length of the air column, is effective length of air column, and the effective length of air column is L by 2. From here figure also, this part L by 2 is only having the air now, so effective length of the air column is L by 2. So therefore we can say that lambda prime will be equal to multiply by L by 2, and this gives us 2L. So if new fundamental frequency is f prime, new fundamental frequency is f prime, so therefore our f prime will be equal to v, that's the velocity of the sound in the air, divided by lambda prime. Lambda prime we just calculated is our v upon 2L, and this is v upon 2L is nothing but our fundamental frequency in open tube, that is equal to f. So we can say this is equal to f, so it means f prime will be equal to f, or we can say from here that new fundamental frequency is equal to original fundamental frequency, original fundamental frequency, which we said is f, and new fundamental frequency we call that as f prime. So options that are given to us, you can see that the option number C is the correct option. So you can write option C is correct. Okay, so this completes the question. Thank you.